Namaskar, I am Anand and you are watching Joint for Education. I am going to dedicate this class to my favorite friend. In this class, I am going to find out the expression of refractive index of a triangular prism. Hope that this class will be useful to the schooling students as well as NEET and G aspirants together with audience who are interested in physics. Let's see. This is a triangle and name of the triangle is A, B, C. So this is a triangular prism. A, B, C. At the first face of the prism, PQ is the incident ray and QR is the refracted ray. But in the second phase of the prism AC, QR is the incident ray and RS is the refracted ray. We extend PQ along this direction and we extend RS in the backward direction. Both intersect each other at this point or the point M. So this angle is known as the angle of deviation and this is generally denoted by a small Greek alphabet delta. So what will be the definition of the deviation, which will be in this way: the angle between incident ray and this one is also known as the emergent ray is called known as said to be angle of deviation. Hope that there is no problem to understand angle of deviation. It is generally denoted by a small Greek alphabet delta. This is the normal at the point Q. This is the normal at the point R. Both intersect each other at this point N. So A, Q and R is a quadrilateral and we know that sum of four angles of a quadrilateral is 360 degrees. So this angle will be 90 degree. This one also will be 90 degree. So sum of these two angles will be 180 degree. So the sum of this angle and this angle in the quadrilateral will be 180 degree. And this angle will be the angle of incidence at the first phase AC and this angle is known as the angle of refraction at the phase AB. Suppose this is the R1. This is the angle of incidence at the phase AC. Suppose this is the R2. and this is the angle of refracted at the face AC. Suppose this is the E. First of all, we consider about the quadrilateral A, Q and R. Consider in the quadrilateral A, Q and R. So the sum of angle A plus angle Q and R equal to 180 degree. Hope that there is no problem to understand at this step. Again, we consider about angle R1 plus R2 plus Q and R equal to 180 degree in the triangle Q and R. So we write down in the triangle Q and R, R1 plus R2 plus Q and R equal to 180 degree. If we consider about these two equations, then here will be A equal to R1 plus R2. Hope that there is no problem to understand at this step. Suppose this is the 1. Again consider about the triangle QMR. So we write down here in the triangle QMR. This is the exterior angle or angle of deviation, or delta is the exterior angle. So we write down here delta equal to, according to the angle property, we know that exterior angle is equal to the sum of the interior opposite angle. So interior opposite angle will be this one and this one. The value of this one will be I minus R1 and value of this one will be E minus R2. So we write down here I minus R1 plus E minus R2. In the second step, this one will be I plus E minus R1 plus R2. Hope that there is no problem to understand at this step. So angle of deviation will be I plus E minus the sum of R1 plus R2 equal to A according to the equation number 1. So we write down here A. At the minimum deviation, we find out what is the expression of refractive index at the minimum deviation. In the minimum deviation, I will be equal to the E and R1 and R2 will be the equal and QR will be the parallel to BC or base. This is the base of the prism. Let's see. So we write down here at the minimum deviation. At the minimum deviation. At the minimum deviation, delta will be dm. So we write down here dm equal to delta. R1 will be equal to the R2. I will be equal to the E. So we recall here, see, A equal to R1 plus R2 and del equal to I plus E minus A. So first of all we write down this one. A equal to R1 plus R2. According to this one, suppose R1 equal to R2 equal to R. So here R equal to A by 2. R plus R equal to 2R, and when A divided by 2 then we get R. So we become succeed to find out the value of R. Again we recall del equal to I plus E minus A. According to this one, for minimum deviation, del equal to dm. I equal to E, so we write down here 2I. I plus I 2I minus A. So here A equal to dm. A equal to, when A move in the left hand side, then this one will be plus. So here will be A equal to dm minus 2I. So here I equal to dm plus A by 2. Of that there is no problem to understand at this step. A move in the right hand side, then we get dm plus A, and when we divide by 2 then we get I. So I equal to dm plus A by 2. Now we have the value of angle of refraction as well as angle of incidence of the prism. Now we have no problem to find out the expression of refractive index. For this we recall the laws of, or second law of refraction of light, that is also known as the Snell law. So we write down here refractive index according to second law of refraction or Snell law, sin I by sin R. Refractive index is generally denoted by Greek letter nu, so we write down here nu equal to sin, and the value of I is dm plus a by 2 by sin r. The value of r is a by 2. So this is the exact expression of the refractive index of the triangular prism. Hope that there is no problem to understand this explanation, and this explanation will be useful to the schooling students as well as G aspirants, NEET aspirants, together with audience who are interested in physics. So this is a simple presentation related to the refractive index of triangular prism, or when a ray of light passes through the triangular prism. For more details, attend online live class of Join for Education. Thank you very much.